Hey guys, what's going on? So today we are going to be talking about some more mathematical animations. Today we're going to be talking about text and equations, and I'm going to show you a really useful tool that you can use to input really complex looking equations into your mathematics quick and easy, okay? Instead of having to type the whole thing out. So let's go ahead and get started. Today we are going to be animating just some simple text. We're going to be using LaTeX, which is code, or which is a tool that is used to type out mathematical equations into documents, and we're going to use that to our advantage in Manim to animate the Weyl tensor. Okay. I've talked about the Weyl tensor before. We're not going to go into the physics of it. The Weyl tensor, as you know, is the traceless part of the Riemann tensor. It plays a role in tidal forces that modulate shape as the objects travel along geodesics. We're not going to talk about this. We're just going to talk about animating the thing and just doing this. That's what's on the screen right now. So the first thing is we're going to talk. We're defining some objects. Our objects are text now, so we need to use this text argument. And here I have mathematical animations. Like I said, I like to name my variables after basically what they are, so I don't get confused. And we have the text is going to say mathematical animations, and I'm going to move it up by 1 unit. I can move it up by 2 units, for example, if I did if I did up times 2, and then play that, and upon playing that, now it's up times 2. We see a bigger gap here. Okay, the other object here, I have Weyl tensor text, and the text is going to show this is the Weyl tensor, and I have this spaced in between the quotes, and then is space the space Weyl space tensor. And the space is required because if there was no space, it would all just read as one single word. So I can do that, for example. Just show you what that looks like. This is the Weyl tensor. And then if I did that, it would look kind of ugly, but we would expect to see this is the Weyl tensor as one word. Okay. So we don't want that. So let's put spaces back in there. This is the Weyl tensor. Now, what's useful about this, using each word as an object in a string like this, is that you can parse out one word, for example, and change its attributes. So, just as an example, I'm taking out red, okay? Or I'm taking out, sorry, not red, I'm taking out the third object in this Weyl tensor text. So Weyl tensor text 3, color red. So we start at 0, the 0th object. The first object is, second object is the, third object is Weyl, fourth object is tensor. So I'm saying Weyl tensor text 3, that's object 3 in Weyl tensor text, which is going to be Weyl. It's going to be colored red, okay? And I don't think I played that. So that is what we get there. Let's also move this back down. Yeah. All right. Now here's the tool. Okay, so I have Weyl tensor. Text. This is my equation. I sandwich the two things in between. I sandwich the equation in between $2 signs, okay, because that's what LaTeX needs. LaTeX needs to be able to look at an equation and say, is this an equation, or is this just a bunch of words, okay? If it's an equation, the identifier is going to be $ signs. Now, I have C underscore, and then I, K, L, and M, all right? So the tool is called Mathpix. Now this is going to help you type out equations much, much faster. And here's what I mean by that. I have my Mathpix installed. If you can go online, you can type in Mathpix, okay? And really, you have to pay a subscription if you want to get some of the perks that Mathpix offers. But upon paying for the subscription, you get the ability to what you can do is you can say you're taking notes, for example, and you write an equation in your notes with your hand, like handwritten notes. You could take a picture of that. You can use that then to upload to your computer, and then from that you could scan your handwritten equation, and it will use AI methods basically to convert that into a nice written equation, a nice text LaTeX written equation for the computer. So it uses AI to recognize handwriting, to convert the handwriting into LaTeX. And what I do, I'll give you a little secret here. What I do for a lot of my videos is that sometimes it won't work very well. Sometimes it'll mistake an A for an alpha or something like that. So what I'll do is I'll scan it. Okay, it looks like I got most of the equation right, but there's some stuff that got wrong. I'll copy that into Word. I can use a copy into Word. So let's do that. Let's say I look at my vial tensor here, and I have I, K, L, M, and I want my M to actually be an N. I'm like, okay, it mistook my handwritten M for an N, so I'll copy that. It says copied, and then I'll go into Microsoft Word, and then I'll copy that into Word like that, just Command V, and then I can change that to N, recopy that. I want the two sandwich dollar signs, and then I'll put that in here. Save, and everything so the M should now be an N. Okay, and let's take a look. It's an N. Now, the reason Mathpix is so useful is because I've taken way more than 840. I think I refreshed this. But here's another formulation of the vial tensor. This would be a pain in the ass to write out in LaTeX. So I could just write it down with my handwritten notes, copy it. Now I don't know if this is going to work, but because of the boxes, I don't know if LaTeX reads those boxes, but let's see. Yeah, it doesn't. We can do it. These boxes are not defined in LaTeX, I don't think. We can do this, for example. So when I'm doing, this is the special conformal transformation operator. This would be a pain in the ass to write out also. So if I did this, quotes that, and it looks like everything's going through. So this is not the vial tensor, this is a special conformal transformation, but you could see now how useful Mathpix is. I can literally just write down with my hands, use AI, and then put into Manim. Super, super easy, super nice. And then we can do all the rest, and now this becomes an object. We can do a bunch of animation stuff with this, right? So I don't like how it is getting blown up that big, so we will reduce the factor, the scale factor, by 1 to 1.5. All right. We can also change the color it gets emphasized to, I don't know, let's do yellow. Let's do yellow B. I don't know what yellow B looks like, but again, we're treating this as an object now that can be modified and animated in many different ways. All right. All right, so we talked about Mathpix. So I'll give you a hint. I'll give you a rundown on why I like Mathpix a little bit more, because it's such an awesome tool. I use GoodNotes a lot to take notes, and when I use GoodNotes, let's say I'm going into advanced physics, for example. I have all these notes on advanced physics. If I were to go to conformal field theory, this is all my handwritten notes, right? And what I can literally do, so this is a handwritten note on conformal. This is the unified conformal field algebra. I could take this equation, for example. I wrote this out, and I can say, and I use Control Command M. This brings up my Mathpix scanning tool, and I do that. And look at that! Look, that's amazing. It didn't even mistake anything, because I had the 0th component of my j and my mu, and then my 1/0th component of my j, and then this is how amazing Mathpix is, right? So then I can copy that. I can put it into here. Right, like that, and then I didn't have to write, and I literally didn't have to type any of this into LaTeX. I just copied it into LaTeX. All I had to do was write it out with my hands, and there you go. That looks interesting. That is not okay. So some things might have to be tweaked. IGHT, right. So this part was not correct. Left, right. Let's see. Sometimes we have $2 signs also. Let's see what happens when we do $2 signs. I don't really remember what the difference is between. Oh, that's what happens. $2 signs is not going to work. Okay. Well, sometimes these equations need to get modified just a little bit when they get put into LaTeX. Maybe we can try the first one here. See what happens there. Now let's see what happens. Okay. The first one usually isn't the one that you want to use, but sometimes I like to just make sure. So sometimes the equation isn't going to work completely, but it's better than starting from scratch. And so, for example, maybe I can do the conformal algebra. So again, Control Command M. I'm going to scan that. Let's see how well it does with my F's. Look at that. It's amazing. Can do it. And then try that. Conf, maybe. I don't know how well this will work. Look at that. And it works. Conformal D, SO, special orthogonal group, D plus 1, 1. So this works, right? For some stuff it might not work, and so you might have to go in and actually see what's going on. But I don't want these videos to go on for too long. So in this video we talked about text, we talked about Mathpix, which is a very useful tool, and we talked about using text as objects that we can animate and so forth. So with that being said, make sure to hit that like and subscribe button, and let's get on to the next. I'll see you guys in the next video.